It's my pleasure to briefly introduce our first keynote speaker, Andrew Burgess. Andrew is a consultant and thought leader in the future of work and the impact of AI and automation. He's a prolific speaker and author, and he writes blogs, magazine articles, books. A new book out this year, Andrew, The Executive Guide to Artificial Intelligence, published by Palgrave Macmillan, and he's also written a book, The Rise of Legal Services Outsourcing, published by Bloomsbury. So Andrew was recently awarded Automation Champion of the Year by the Global Sourcing Association, and Andrew is here to advise you on how to start your AI journey. So please welcome Andrew Burgess. Thanks.
Thank you very much. Welcome, everybody. I'm going to talk to you about artificial intelligence because it's going to be, I think, a recurring theme over the next 2 days. And a lot of people don't really know what AI is, although some people might pretend or make up what they know about it. So hopefully I'm going to try and explain that in very simple terms to you. A little bit about me. As Vincent said, I wrote The Executive Guide to Artificial Intelligence, which is available from all good booksellers, Amazon, etc. And I write for some of these magazines like Professional Outsourcing and Disruption. And I've done some work with the Royal Society, the All-Party Parliamentary Group on AI. I've spoken there as well, and the Law Society, and do a newsletter called That Space Cadet Glow with lots of interesting stuff about AI and other technologies. So that's enough about me. One of the questions that I'm asked an awful lot by people is, how can we use artificial intelligence in our business? Another version is can I have an AI, please? And of course, this is the wrong question to ask. What people should be saying is, what are my business challenges? What are my objectives? And can our AI help to meet or deliver or solve those challenges? Now, the first bit is really up to the business to know and understand. And if you don't know that, then you've got bigger problems than I can solve. But the second bit is where I can come in and help you understand and sort out the strategy around AI. But we need to know what AI is first of all. So the next question we need to ask ourselves is, what the bleep is AI anyway? So for the next 40 minutes or so, I'm going to try and explain what that is, use some examples of AI in action today, and then some of the risks as well, and how to start to think about AI. So a lot of people will describe AI almost like a game of Scrabble or a random word generator. There's all these terms like artificial intelligence, machine learning, cognitive, intelligent automation, and people use these words interchangeably, and the more you read about it, the more confused you get. And there's a lot of this down to lazy journalism. A lot of it is down to misunderstanding. Today, I'm just going to use the term artificial intelligence, which is really the catch-all term for all of these. Some of them are kind of subsets of that. Machine learning is a way to implement artificial intelligence. But I'm just going to use AI as a kind of generic catch-all term just to keep things simple. So one of the things I did a few years ago to try and work out how to explain AI to business people, sat down in a dark room for a few days, put a wet towel on my head, and read lots of stuff and worked out how to build a framework for AI. And this is kind of the theme that runs through the book that I mentioned earlier. So the first definition that you come across when you start reading things is AI is the theory and development of computer systems able to perform tasks normally requiring human intelligence, which is a reasonable, that's the dictionary definition, but it's a little bit circular because it involves the word intelligence. And if we want to understand, to debate what intelligence means, that's a whole half hour or longer to do that. So what I did was try and explain AI in terms of the capabilities, what it can do, rather than the actual technical side of it. So I built this framework, and it's got three kind of main sections here that kind of meta objectives that AI can achieve. First one's around capturing information. The second one's around what is happening with that information. And then once we understand what is happening, then we want to understand why something's happening. So you almost got a bit of a flow of that information through. And in each of these, I've got different capabilities. And I've kind of boiled down what those capabilities are into these different sections. So the first one is around image recognition. And this is typically something like, we want to recognize a picture of a dog. And this is actually my dog. I have to have a picture of my dog in every presentation. What I'll do, I'll go through each of these in a bit more detail, but I'll just introduce the framework to you first. So the first one's around image recognition. The second one is the same idea, but with sound. So taking words that people are saying and understanding what those words are. And at this stage, we're not trying to understand the intent of those words. We're just trying to understand what those words are. So when we come on to what is happening, that's when we want to understand the intent of it. But at the moment, we just need to understand those words. So taking a sound file or recording or a telephone call, here it's saying Bariyard dancing in September. I only put that up there so you're going to be singing Earth, Wind and Fire for the rest of the day. But it's taking that and breaking it down into those individual words. Third one in here is around search. So this is taking the written word and extracting metadata and words out of unstructured text. And these first three are all examples of unstructured data. So images, sound, and the written word are all very unstructured. So this is what AI is very good at, is taking unstructured data and making it structured. And particularly if any of you are familiar with robotic process automation, or RPA, those robots need structured data to function, to work on their processes. So AI is a very good precursor to RPA to make that data structured. But also you've got structured data coming in, and this is the idea about big data, and we look at clustering or analyzing that big data to look at the patterns within that. So we're capturing all this big data, and we're trying to find the patterns within it. So we've got ideas of unstructured data and structured data. Once we've got that, then we want to understand what is happening with that data. So the first one there is around natural language understanding or natural language processing. Some of you have heard the phrase NLP. A big use of that is in chatbots as well, but this is where we're taking, for example, those words that we found in the capturing data and understanding the intent of what somebody is saying. What do they actually want out of the words that they're saying? The second one is around problem solving or reasoning, and typically used in things like route navigation, finding the optimum route to something. So it's all around optimizing a process or a problem that you've got to solve. And the last one in here is around prediction, what's going to happen next. And again, using particularly a lot of that structured data, that clustering data, to work out what's going to happen next in a process, for example. So once we understood what is happening, then ideally we want to understand why something's happening. Now, this is where we get into the realms of science fiction, or at least labs here, because everything I've spoken about so far is all available to go and buy or build out in the market there. These are all, everything I've described as well is examples of artificial narrow intelligence. And AI is very good at doing one thing very well. So, for example, when we talk about image recognition, recognizing pictures of dogs, you can't use that same AI to do sound recognition or speech recognition. It's a completely different system. And it's so narrow that even if I had a system that was trained to recognize pictures of dogs, it couldn't recognize pictures of cats. I'd have to wipe its memory and retrain it to recognize pictures of cats. So it's very, very narrow in its capabilities. So when you're building an AI solution, you're tending to put some of these together to build an overall solution. For example, taking those sound files, telephone call, breaking it down into understanding what the words are, and then understanding the intent of that, and then maybe using problem solving and reasoning to actually solve the problem that the person was talking about in the first place. When we get to why it's happening, we're putting all these things together and trying to understand why something's happening. It's like cognition and understanding. This is what the brain is really, really good at. We can take a concept like, I've learned how to play chess, learn how to play drafts, and I want to learn how to play chess. I can take some of the concepts of drafts and use that to learn how to play chess. It's an 8x8 board. It's got pieces that I move around, etc., and there's an objective at the end of it. But again, with AI, what it can't do is take the learning from drafts and take it to chess. You've got to wipe its memory and teach it how to play chess. So if anyone says that AI system has cognition or understanding, they're going to be lying. This is just really, there's some interesting stuff being done in labs by DeepMind on this, but called transfer learning. But at the moment, this just doesn't exist. So when you're building your AI systems, you've got to look at the very narrow capabilities. So that's the framework. And I think this is really useful when you're looking at AI problems or AI solutions to kind of break it down and boil it down into those individual capabilities. So let me go a little bit more detail into each of these. So image recognition. So I'll give you a vacuous example. First of all, this is an app called FindFace. It's a Russian app. And what it's able to do is recognize people's faces. And it does that because it's based on a social media application called VK, or VContact, which is kind of the Russian equivalent of Facebook. The difference between VK and Facebook is your profile picture must be made public. It's mandatory that it's public. So what you have here is a database of the majority of Russians' faces. And we know that AI works on data. It needs data to extract value. So what they've been able to do on this actually a mobile phone app is you can point it at somebody's face, and it will recognize them, because it is looking at the VK pictures, to apparently a 70% accuracy. Now, you can see this is the homepage of the site, and you can see the sorts of people that are expecting to use the app, which I think is pervy old men. But it does demonstrate the capabilities of AI if you've got enough data here. Another example, a bit more serious, is in the insurance business. So again, this is an app called Tractable. And if you crash your car, and assuming you survive, you want to get your insurance claim in as quickly as possible. So you take some photographs of that damage. You send them to, it's automatically sent to the application. And you can see here, using image recognition, the app identifies which parts of the car you've taken the pictures of. And it's American, so it says left fender, left headlamp, front bumper, hood, etc. So it identifies the part of the car, but it also recognizes where there's damage, and it assesses the damage and says, right, the left fender here needs repairing, but the front bumper I can replace. So, and it knows what sort of car it is, it knows what needs to be replaced or repaired, therefore it can give you your quote straight away. So within minutes of you having your accident, you've got a quote and instructions about how to get that fixed. So very good from a customer experience point of view. Other examples is in content piracy, trying to stop that. So if you're looking at a football game, for example, very difficult to, with moving images to use image recognition here. But, for example, you can identify particular logos, etc. So if this is being streamed from a pirate site, you can identify, if it hasn't been blocked, the source of that. And you can even start to look at the team's colors and identify the teams there. And also in another sporting example, with boxing, you could be able to even recognize people's faces as well. So some good examples of that in terms of content piracy. From voice recognition, everyone has kind of voice recognition on their phones, whether it's Siri or Cortana or Alexa. And they work kind of well most of the time, depending on the environment you're in. But it can be used quite effectively in contact centers. So there's some new applications coming around which listen dynamically to the calls going on and can start to identify where there are issues with those calls. So it's listening out for specific phrases or patterns within what people are talking about, and then we'll flag those to the supervisor. So here's a system that's saying, well, there's some yellow issues here where they've got, it's an American system. The mini Miranda is the bit where you have to tell somebody the call's being recorded. If they've forgotten that, then it starts to be flagged. And then the red ones are where the customer is generally quite angry, and you can see the issues there. And then if you kind of can click on those, it tells you exactly why it's flagged those ones. So it's saying actually that the agent's done quite well at the beginning because it says, how can I help? The caller says, terrible, is not happy, I want to speak to your supervisor. So it's these sorts of phrases that are being identified through the AI that start to flag it up. And we can see, the agent's done quite well because it's done empathy, sorry to hear that, etc. So they're trying to bring the customer on. So you've got a very good evaluation of those calls, but in real time, so you can actually take action dynamically. Another example of this is with Deutsche Bank, so a big investment bank, and their Their dealers do lots of deals with their clients over the telephone, but the bank wants to make sure they identify fraudulent behavior or non-compliance in those calls. And what they used to have to do was record all of the calls and then listen to a very small sample of those calls, maybe 5% of those. And then people would listen to them. If they identify anything that sounded a little bit suspicious or non-compliant, then they would go and talk to the dealer, and depending on the severity of that, they'd either wrap them over the knuckles or march them out the door. But there's some risk there because they're only capturing a small sample. So again, they're using AI to actually listen, in inverted commas, listen to all of the calls, 100% of the calls, identifying the patterns within those calls that might suggest fraudulent behavior or non-compliance. So it's beyond just listening out for specific words like bribe or whatever. It's actually looking for the patterns within that suggest that. And of course, once it's identified the suspicious ones, then it sends it to a human being, and the human listens to that and then takes appropriate action or not, depending on the severity of it again. So a really good example of how the value of AI is beyond what people typically think of automation in terms of replacing people. Here's one where we're augmenting their capabilities, and the value here is cutting out fraud and non-compliance in the deals. And you imagine the amount of money that goes through Deutsche Bank's investment bank every day, huge amounts of money that can be mitigated through risk here. The third one we had in terms of unstructured data and capturing unstructured data was with search, and this is the written word. And that can be from semi-structured data right through to unstructured data. So by semi-structured data, I mean things like invoices, where the information is more or less the same on the document every time, but it moves around, or it could be slightly different. So on an invoice, the address might be in the top left or the top right. The date might be in UK format or US format. And there might be a VAT line, or there might not be. So if you wanted to extract the information from that invoice to put into your system of record and do something useful with it, you would typically have to create a template for every different version of those invoices that came through. But now AI is able to cope with that ambiguity. So you would train it on a number of invoices, and it's quite a small number of invoices, and it starts to recognize the patterns of those things. So it's looking for a pattern of text that looks like an address. So it doesn't matter where on the document it is, it can find that pattern of words and identify that as an address, extract that and put it into your system of record. And the beauty of this is if it finds something it doesn't recognize, like delivery costs, for example, it would then flag that to a human being. The human being would say, right, yes, that's delivery cost, that goes here. And then it's learned. So it's learning on the job every time. So it's just like having a school leaver working there. You just keep training them, prodding them, and telling them what to do. And they get better and better at their work until they're as accurate as they can be. Slightly more unstructured, but still semi-structured, are contracts. So in a contract, very long documents, very wordy, but within that, there's some data there that's generally always there. The name of the parties, the value, termination date, limits of liability, all this sort of information. But again, if you wanted to extract that, you would have to read through that. Typically, this would be the sort of activity you might outsource, but people would read through that and then find the limits of liability clause, find the limits of liability, and put that into your system of record. So again, AI is able to read through those contracts, identify those clauses automatically, and extract the data and put it into your system. So if you're a company like a law firm or a big multinational that has lots and lots of contracts, you're able to identify and mitigate your risk of your portfolio by having all this data to hand. And if there's a question that you didn't know, for example, if the UK was, God forbid, going to leave the EU, you might want to look at all of your contracts that are under English and Welsh law and all the ones that weren't, and be able to assess very quickly your exposure to risk around that. So it's very useful to manage that and managing risk. When we look at unstructured text data, again, AI is able to classify those documents coming in. So a really good example of this is Virgin Trains. So if you email Virgin Trains, I guess you're going to be complaining. You might actually want to compliment, I suppose. But you might say, for example, the Wi-Fi wasn't working on the 1256 from London to Manchester. What are you going to do about it? So those emails are actually read by some software, so someone's in-stream software in this case. And it's, first of all, it does some validation. So it says, right, this is a complaint. This is a complaint about the Wi-Fi. It's about this particular train. And it will check whether there's a train at that time. Have other people complained about the Wi-Fi on that train? Are you one of these people that's always complaining to people? And based on all that information, they will then send that to the right person within the organization. So Virgin have been able to reduce the time taken on those initial stages, the resources applied to that, by 85%. And what they've done, those people are now working on the later stage of actually dealing with the problems rather than just classifying them in the first place. So again, customer experience has improved through using AI. Still on capturing data, we want to understand around the big data side of it. So I talked about clustering. This is a really simple example, but I think hopefully demonstrates the approach. There's only two features on this graph. So this is actually footballers. One axis is speed, so how fast the person can run, and the other one is height. So if you put all that data in and you clustered it into these different things, you're essentially getting different positions on the football field. So all the short, fast people are strikers, and all the tall, slow people are defenders, generally. It's that sort of thing. Now, that's something, a human could do. If somebody else joins a team, you measure how fast they run, you measure their height, you say, right, you're a striker, or you're a defender, whatever it is. But we can do that. That's within our capacity. But the challenge comes when we've got, in this case, 784 dimensions. So we've gone from 2 to 784. And that's a much bigger challenge that's beyond the capabilities of the brain. But AI can do it. This is actually looking for handwritten numbers. So it's looking at all the different features of handwritten numbers and grouping those, clustering those into different groups so it can identify what they are. Once you've got that data, then you might want to be able to use it to predict something, to do something useful with it. So, classically, this is done on Amazon. So you've bought this book, therefore it's going to recommend that you buy that book. It's predicting what you want to buy next, and obviously some very good recommendations here, if you didn't get my subtle advertising here. But behind the scenes, there's lots of very complicated clustering and pattern matching going on for what's actually a very simple outcome. You bought that book, therefore you want to buy that book. But that can be much more challenging when the data you're feeding in is more esoteric. So here's the European Court of Human Rights. And what some academics did a few years ago was identify all the different features of the cases that go through the European Court of Human Rights and try and predict the outcome of future cases. And they're able to do that with a 79% accuracy. Now, it's not 100%, but these venerable people here, we're getting close to actually being able to replace some of these people, maybe even replacing lawyers. That'd be a great world to live in. By looking at all the different data that we got coming in. And the challenge, if you're a data scientist, I think probably some here today, is what are the features of those cases that are going to influence the outcome and which aren't? And that's kind of the art of the data scientist to identify that. But to get to that level of accuracy on something so esoteric is a really good approach to use AI. Another example where we've done clustering and then prediction is with PayPal, where they're trying to identify fraudulent transactions. And rather than like with Amazon, where they're looking at, well, here's some buying behaviors, and here's this other customer's buying behaviors, and we're correlating the two things. Actually, you belong to this group of customers who have bought this book. With PayPal, they're looking for the anomalous transactions, the ones that don't fit into it, so the ones that are fraudulent. And because the computers are much faster now and they've got so much more data and it's so much cheaper to store this data, PayPal are able to identify these fraudulent transactions almost in real time. So the average fraudulent transaction rate for merchant services companies like PayPal is 1.32%. So that number of transactions are fraudulent. With PayPal, because they've got these systems in place, theirs is 0.32. So again, imagining the amount of money that goes through PayPal every day, reducing your fraudulent transactions from 1.32 to 0.32 means an awful lot of value for PayPal using these systems. Then when we come on to natural language understanding, as I said before, a lot of that is used in chatbots. And this is one called Amelia. It's from a company called IPsoft, American company. The The avatar that is pure window dressing, has no real value to this at all, apart from people might want to talk to a creepy lady for a bit. I don't know, it might make them feel better. But actually the real value is here within the text. Everyone's probably had a chatbot experience before, and it's probably been wanting a little bit. And there's lots of different versions and approaches for chatbot. I always tell my clients, if you're going to do chatbots, do it properly, because it's a very quick way of ruining your reputation as a company is having a bad implementation of chatbot, because once people have done it and it hasn't worked, they're never going to come back and try it again. So make sure you do it properly. IPsoft is kind of one of the leaders of that. They're very good in terms of the natural language understanding, being able to feed in data to train it very, very well. It's also quite expensive as well, and you can go down to approaches where actually you can do chatbots for free, which I wouldn't necessarily recommend, but there's generally a chatbot approach that works for most people. The opposite side of natural language understanding is natural language generation. So same technology, but just kind of in reverse. And what it's able to do is take data and turn it into natural language. So here you can see financial results turned into financial reports for, this is Associated Press, use this system. And what reads actually like a very human-like report. And even if you kind of reran that on the same data, it would come out with a slightly different wording, because there's intelligence to make it sound different and fresh every time. And people use this for weather reports, so very hyper-local weather reports. You can get a personalized natural language sounding weather report for you, for sports reports as well. Anything where there's lots of data and you want to have a natural language kind of narrative around it, you would use NLG. And then we come to problem solving. I think this is where things get kind of interesting. I talked about it, the ability to optimize processes or solve problems. And the best way to explain this is through Space Invaders. And this is actually an AI playing Space Invaders. And some of you may know a company called DeepMind, which is owned by Google, probably the foremost AI company in the world right now. And a few years ago, they taught a system to play Space Invaders, but they didn't actually tell it how to play Space Invaders. All they did was say, maximize that number in the top left-hand corner. I score as many points as possible. So by a kind of an extreme trial and error, the system learns how to play Space Invaders. So at first it does nothing. It gets shot, so therefore it's died. Does that 3 times, it loses the game, hasn't scored any points. It might hide under the barriers, so it doesn't get shot, but it's still not scoring any points. But if it moves outside the barriers, starts shooting the Space Invaders, it's scored points, so it's closer to the objective. So this is good. I'm closer to the reward point. And then if I shoot the big red guy at the top, I score even more points. So again, through this extreme trial and error, it learns how to play Space Invaders, and it can get effectively better than the best people, the best humans at playing these games. And it's done very similar things with Breakout and other games as well. And you take that to an extreme, and some of you may have heard of, again, it was DeepMind's system called AlphaGo, and it beat the world's best player, Lee Sedol, at the game of Go. And Go's, as you see, it's a 19 by 19 board, Chinese game. A lot of humans, the players will say it's based on a lot of intuition in terms of how people play, because it's very complicated. There's more possible moves on that Go board than there are atoms in the universe. So it's impossible for a person to kind of compute all that, and impossible for a traditional computer to compute all that as well. But DeepMind were able to create a system that was able to beat the best pro in the world at this, using this idea of reinforcement learning, of extreme trial and error. And they trained it through using lots of examples of human games, so human versus human games. It learned how to play the games and the patterns that people used. And then it started playing itself. And because it's playing itself, it can do that much quicker. And that's the bit that kind of jumped it above human ability, because it can learn and just get better and better very, very quickly. But those are just games, so what's the use of that? So Google have used these sorts of systems in their own data centers. So they were able to optimize the cooling systems in their data centers and reduce their cooling bills by 40%. So again, if you think about the value of AI, this is around, it's not, again, not about taking people out of a process. This is about reducing the cost in the data centers and also the environmental cost as well of doing this. So that's just one data center, but if you imagine doing that, reducing the cooling requirements of all data centers across the world by 40%, that's a huge environmental benefit as well. But a lot of what I've been talking about, that all those things exist today, but really they are just the tip of the iceberg. And if you go back to the example of AlphaGo, the original bit I talked about was a couple of years ago now. Last year, they created a new version of that system called AlphaGo Zero. And what they're able to do was beat, again, played best player in the world at Go and beat him and that. But the really interesting thing here is that they didn't train the system on human games. So just like the Space Invaders piece, they got one AlphaGo Zero system and another one to start playing each other at Go. And again, at the very beginning, they were really rubbish at it, and they didn't do very well. But because they can play very quickly, within 4 hours, they were as good as an amateur. And then within 7 days, they were better than the best player in the world. And the really interesting thing for me here is that they were able to do that without being encumbered by human thought and the way that humans play games. So they were coming up with moves on the Go board which humans wouldn't have thought about. The professional players were looking at it saying, I would never have played that move, but it was a good move, and the human players are learning from how AlphaGo Zero has been playing this game. So you can almost think of it as like the beginning of creativity here, and there's a talk later on this afternoon about AI and creativity. But you can see the germs of creativity here because the computer's starting to think for itself without having been trained by human beings. So does this mean that we're all going to be taken over and run by Skynet? I don't think so, but there are risks within AI, and there's a number of risks, and I just wanted to cover a few of those as well, because I want to leave you with the idea that this is all great, and I can just turn a switch, and I've got all these benefits here. So the first one that is very important to recognize is this idea of the black box. A lot of AI, when you're building these algorithms, the way that it makes decisions can be very opaque. So, for example, if I've got a system that approves loans or rejects loans for a company, assesses the loans, certain sorts of systems, if you said, right, my loan's been rejected, why was it rejected? A lot of AI, you won't be able to say, well, it's because of your postcode or your age or your salary. All you can really say is, we put lots of data in and the machine made this decision. Because this is the idea around machine learning. It's the machine that's doing the programming itself. So to try and reverse engineer that is very, very difficult. Now, it's not impossible. And as a general rule, the simpler the algorithms you use, the more transparency you get. And there's lots of systems now, or a number of systems that are starting to be able to kind of do that reverse engineering on the fly. But what you've got to be careful of, particularly if you're in a regulated industry, is making sure you have the right level of transparency coming out of the end of it and using the right approach to AI. Another risk within AI is around bias. This is a sample of a large database which has 13,000 faces in it altogether. It's called Faces in the Wild. And a few years ago, companies like Google and Facebook and people like that were using this to train their facial recognition algorithms on it. And if you look at this is just a sample, but it's kind of representative of it. There's a lot of white people there, and there's a lot of men. In fact, in the whole data set, 85% of the people in the data set were men, and 89% were white. So what that means is, as you're training these systems, if you are, and you want to recognize a face, if you are, for example, a woman of color, it's going to have a much more difficult time recognizing you than it is a white person, a white man, because it hasn't been trained well enough. So this was done, there was no malice when people were doing this. They just didn't realize. And people have to be very proactive and start to question the data they're feeding in. Is it going to give me the results I want? Particularly if you're looking at selecting CVs for jobs as well, making sure that you're debiasing all that data, because people have unconscious biases. So if you say, well, this is how we previously selected all our candidates, therefore we're going to train the AI to do that. If you've got biases, they're going to be baked into our algorithm, and that algorithm is going to have those exactly the same biases. So you've got to make sure that you de-bias it. And there's some very good examples at the moment of where even if you take out all of the gendered pronouns in the CV, the AI can still detect, again, naively, still detect maybe the particular school that the person went to, if they were a hockey player or a football player. All these things suggest gender, and it's really difficult. But something you have to do is de-biasing the systems as you train them up. And then again, another picture of my dog. One of the things that you have to realize about AI is its naivety. So we talked about recognizing pictures of dogs on the internet, but what it doesn't do is recognize what a dog is. The AI system doesn't inherently know what a dog is. All it's done, you've given it lots of pictures, so patterns of pixels, and you've labeled them dog or not dog, and you've given it another picture, and it's recognized that pattern, matched it with those, said, yes, this pattern of pixels matches close enough to that pattern of pixels, and those are the ones you've labeled dog, therefore I'm going to label this one dog. You could have labeled it horse or whatever it is, and it would have called it horse. It doesn't recognize what that is. So one of the dangers and one of the things that you have to not do is kind of anthropomorphize the AI and give it more credibility and more capability than it actually has. Understand exactly what it is and its limitations on this. So just to kind of close, going back to the original question that we were asking before in terms of can AI deliver value to help me meet my business objectives? There are two different approaches you can take to that, and illustrate that through the story. So these are two kind of forefathers of AI back in the 1950s, Marvin Minsky and Doug Engelbart, and they were working at different universities, had quite different approaches to AI. And there's this story that Minsky went to Engelbart one day and said, I've had this huge breakthrough. We're going to make the machines intelligent. We're going to make them conscious. And Engelbart turned to Minsky and said, well, you're going to do that for the machines. What are you going to do for the people? And this argument about are we going to use this technology to replace people or to augment them has been going on ever since the 1950s. So hopefully from what I've shown you so far in terms of those examples, a lot of those are around augmentation of our capabilities, helping us make better decisions in our business lives, helping us do things better rather than just replacing what we're doing. So thought I'd leave you with is let's not concentrate on replacing the burger flippers with automated arms. Let's look at, just like Steve Austin, trying to make us better, stronger, faster human beings. Thank you very much.
Well, thanks very much, Andrew. I'm sure there are some questions coming off that fascinating presentation. Anyone want to start the question? Yeah, Anne, I've got it.
I was really glad that you touched on bias, because what struck me when you showed the venerable judges, where they were 5 white people, 4 men, 1 woman, judging, and you were talking about human rights, I would assume on at least pan-European, but potentially global scale. So what can organizations do when their body of knowledge is based on that bias, and now they want to go into, they want to do more augmented decision-making, but don't want to incorporate the bias? Like, how do they even determine what it is?
Yeah. It's really difficult. It's a really hot topic at the moment as well. It's by bringing in more diverse people. So it's not a technology problem, it's a people problem. Bring more diversity into the organization, more women, more people of color, and just testing and checking and making sure that these are the right things. Every white man, myself included, has been brought up in the last 50 years of this is the way that things happen, and we have to challenge ourselves. Me Too movement as well. We have to keep challenging ourselves to do the right thing, and those biases are deep in a lot of people.
Can they be changed though? Once it's like what happens if you realize you have an AI and it has those biases?
Yeah, so you can rework those, but it's a case of retraining the AI again. So you can maybe add in new data that kind of starts to skew it back to a neutral position, or you can kind of just wipe it and start again and retrain it as well, yeah. But it's a huge challenge that people have to look at. Thank you.
There's another 2 more questions.
Hi, it's Jay Wilson from Elsevier. I really like your talk, and particularly what you were saying about the important thing is what we do with AI.
Yeah.
And I just wanted to ask, could you give us sort of one thing that we can do as, you know, people working in AI to help overcome the problems in how society deals with AI negative effects? So as a community, I mean, I really liked what Vincent was talking about earlier in terms of, you know, ConTech as a community. So what can you say that we can do collectively to help society make good decisions around AI?
I think the important thing is around education. You know, and I started the talk talking about people don't really understand what AI is, and I do a version of this talk, I call it the silent revolution, because AI is around us already, and it's helping us make decisions. And if people don't realize those decisions are being made for them, you know, social media is a great example with Facebook and other social media channels are available. But, you know, with something like Facebook, people don't understand, if they're not well read enough, they don't understand the impact that AI is having on the decisions and the influence in their lives. So just being able to educate people and tell them about what it is. And, you know, AI is such a amorphous subject. So trying to break it down into those different elements, saying, well, you know, let's focus on that element of image recognition or whatever it is, facial recognition, and let's understand that. And people can, once they start to see that, then they can, you know, they understand how it's affecting them. So I think, you know, it's a short answer for a very big thing to do, but, you know, the more you can tell people and explain it to them in words of one syllable and not scare people and, you know, ignore what happens in the movies. It's like AI is just mathematics. At the end of the day, it's just some very clever maths, and we can actually impact that.
Yeah, thanks very much. I really like that because, yeah, with AI, it's really about optimizing functions to make predictions and things like that. And I thought your example was really great. And I think I agree. The most important thing is that people don't think AI is conscious.
Yeah.
The importance is how we as a society actually implement it.
It's just a tool. Yeah, exactly.
Thank you.
Yeah.
I think there was another question on the right. Yeah. Yeah.
I can. Yeah, it's coming.
Martha from Sage. I was interested in some of the work you've been doing with government and how you feel that government in the UK is sort of responding to both the opportunities and threats offered by sort of AI and emerging technologies.
So the thing I mentioned was I spoke at the All-Party Parliamentary Group on AI, and that's a group that meets every 3 months or so, and people give evidence to that, and that's meant to influence parliamentarians in terms of their policy, etc. And there's been a few good reports on that, about how AI should be used, which is all good. And what we're doing is we're getting the message out to the people that can actually make a difference. My only criticism is that at the end of the day, it's a big report, and big reports are great as long as people actually read them and do something about them. If it sits in a drawer or somebody's desk, then it's not going to have any use at all. So I think people have to get out there and talk about it and do it rather than just reading or writing about it as well, I'm afraid. But, you know, it's the right direction, I think, on that. But more needs to be done, I think, you know, particularly around education. We can all talk about people need to be better trained in computer science and data science, etc. But the changes have to happen very early on. You know, my kids are sort of 17 and 21, and they've gone through school without having to do any computer science at all. And now they're coming into the world, and that's everything at the moment. Why wasn't that started before? You know, and I always use the example of Napoleon said, you know, the best time to plant a tree is 25 years ago, but the second best time is today. So just get on and do it. You know, that's what we've got to do. So it needs to start changing education now to make sure the impact's later on.
Thank you. There's another question here.
Hi, thanks. Hi, Tommy. I'm from EBSCO in the US. Talking about education, also, do we need to talk about transparency as well? So in the US, we suffer from a huge problem with information illiteracy, massive polarization of society, being influenced, fake news, all this kind of stuff. We've seen what's happening here as well, and things about exits and all that. Do we need to start declaring more publicly when AI is used and how it's used? I'm just thinking, how the GMO things raged along and all that kind of stuff, as well as education. Do we need to start declaring when these robots on the phone calling us up in the middle of the night are really robots or they're really people, and where that information's come and how it works?
Short answer is yes. The challenge, so one good example of that is Google Duplex, which some of you may have heard. It's the demo they did at their conference about 6 months ago, where they booked a hairdressing appointment. So it rang up hairdressers and very natural language sounding, even ums and ahs in it, etc. Booked a haircut, and the person on the other end wasn't aware of that. Great demo, but afterwards there's a big pushback saying, well, those people deserve to know that they're talking to a robot rather than a person. So Google are now committed to actually declaring that you're talking to a robot. And if you're doing that, then it kind of negates the point of having all the cleverness of the speech in there. And when you're talking to a chatbot, if you know it's a robot, you don't do the niceties. You just get down to the bare bones of the conversation. So I think that's one element. The other big challenge, I think, is where do you draw the line in terms of defining what AI is? And people, the same challenges around, should we be taxing robots as well? That's one of the other big debates at the moment. But then when is a robot, and when isn't it a robot? And there's no kind of very black and white process here. So every chatbot has AI in it because it has natural language processing. Every time we use our phones, again, there's tons and tons of AI built into our phones. So where should we be saying, you don't want to a warning up every time you use your phone that we're using AI. So I think that's going to be the big challenge. AI, one of the definitions of AI is it's always 20 years in the future, and we've got AI here today. So you just got to be, is it then when it becomes socially acceptable, you say, right, we don't have to tell people now, and we can let that one go. But it's actually this new bit of AI that's coming through. So there's a huge challenge in how you do that. I don't know the answer to those, I'm afraid.
Well, thank you. Thanks very much, Andrew. That was fascinating.
Thank you.